Hello students, this is Mrs. Spence and we are going to run through a few slides. There's actually 14 slides in this presentation. I strongly encourage you to hit the pause button between slides and take notes on the slide before you go on to the next slide. Your pause button needs to be very handy because I am not going to give you time to write things down. I'm going to explain slides and talk about what's on the slide, but I won't give you time to write them down. All right, I kind of expect you to use the pause button and write these things down. So let's get started. This unit is on, I will kind of go with the slides here. I hope you enjoy my wonderful drawings. They're to entertain you while you're taking notes. This whole lesson will be on three-dimensional figures, kind of revisiting what we talked about earlier in the year, except we'll add more of the trigonometry that we've learned since then, and also all the right triangle things, sine, cosine, tangent, those kinds of things, regular polygons. But anyway, so we're going to kind of incorporate that into our three-dimensional unit of volume and surface area. So let's get started. This first slide is 12.1 in your textbook, representations of three-dimensional figures. Basically, it's just how to draw three-dimensional figures. You have a front view, which is done, this front view is done right here with a rectangle in the front and then parallelograms back here in the back. But you can see the isometric view is made up of all parallelograms. Every single one of the shapes is a parallelogram. You're mainly looking at a corner view, whereas on the front view you're looking at the front, and this is all right angles. But when you're looking at an isometric view, you have the front, you have the right side, and you have, this would be the top. I'm not sure why that didn't come through, but we'll just add that right now. This is the top. Oh, there it goes. It came through. Example 1 is basically drawing a right triangular prism 3 units high with 2 sides of the base that are 2 units long and 4 units long. So I'm drawing this right triangular prism, an isometric view. You can see here that this side is 2 units long, 1, 2. This side over here is 4 units long, 1, 2, 3, 4, and we're talking spaces, not dots. And then the height of this thing is also 2 units. So 2 sides of the base that are 2 units long, and 2 sides, I'm sorry, one's 2 units and one's 4 units. And the other base is a 2 by 2. All right. Example 2 says use isometric drop paper and these orthographic drawings to sketch a solid. So orthographic drawings are a front view, just the right side view, the top view of this building, and the back side of the building. And so if you do it as an isometric drawing, this is what it will look like. And a little shading in there to help the three-dimensional effect. So you see this is the front view, this is the right side view, this is the left side view, and this is the back view. And this is just a little guy that I drew. But anyway, so you need to be able to do the orthographic drawings. Remember, the orthographic drawings are these drawings, and this is the isometric drawing. what is a cross section? Glad you asked. First of all, let's talk about what a tetrahedron is. A tetrahedron is a polyhedron with 4 faces. It's got 4 faces, 1, 2, actually this one I think, yeah, it has 4 faces. It's got 1 on the front, 1 on the bottom, and 2 on the left and the right. So here's the bottom. There's 1 face over here, 1 face over here, and then of course the face on the front is the last one. A cross section of the tetrahedron is a lot like cutting the 3-dimensional figure, just basically slicing it. So you're taking the 3D figure straight through the middle with a slice, just like you're slicing a piece of cake. So notice in this drawing that the shape that's created is not a right triangle, but just a triangle. Now it does depend on how you cut this thing as to what shape will be created. And it also depends on what the 3D figure is. The 3D figure could be a cylinder. If you're cutting a cylinder straight across the middle, your faces are going to be circles. If you cut it straight up and down from top to bottom, assuming that it's standing upright, then you're going to get a rectangle. But it just depends on what the shape will be. You can see that the shape here ended up being a triangle. Now, let's talk about surface area of a prism and a cylinder. Alright, what I'm going to draw for you, or what I'm drawing for you now, is what's called a hexagonal prism. Notice the reason we call it a hexagonal prism is because it's got hexagons for bases. It is a prism because the bases are congruent and they're parallel to each other. Now these top and the bottom are called bases. They're the matching, the top and bottom is also how you name it. And then you've got lateral faces, which are the rectangles around the outside. Notice this thing has 1, 2, 3, 4, 5, 6 lateral faces. 6 of those. Lateral edges, it's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 lateral edges. And of course the vertices, which I didn't put on the picture, these are your vertices, okay, where your edges come together. Those are your vertices. This is called an oblique hexagonal prism. I'll just let this video catch up a little bit. It does actually look like it's going to fall over. Yes, it does look like it's going to fall over. All of its parts are the same as a regular hexagonal prism, except the lateral edge is no longer the height of this thing, or no longer the altitude, and are not the same. They're not the same, so your lateral edge is literally on the edge of the hexagonal prism, but your altitude is still the height of the prism, which is kind of outside the hexagonal prism. So you still have 18 lateral edges, but you also have a height as well. Alright, what is lateral area? Lateral area is literally the area of the faces on the outsides. In other words, it is the area of all of the lateral faces. which does not include the top and the bottom base. So the top face and the bottom face are not included in the lateral edges. Alright, you can see here that we have the formula for area of a rectangle, A times B, because we have a rectangle that is A by B, plus C times H, so because we have a rectangle that's C by H, and in the back side we have another rectangle that's BH, B times H. We add all that together to find the area. The area of those three faces is the lateral area. Now, if you remember from algebra, we can factor out the A, the C, and the B. We can pull all those out to the front of our equation, which is where I stopped the video. So if you will finish watching the video and you'll see the B come out, and then multiply that by the H. So what we have here is the perimeter of the bases times the height. Now you can see it when it's unfolded, when the prism's all unfolded and laid out flat. The area of that rectangle in yellow is A plus B plus C times the height. In other words, the perimeter of the base times the height. So that's the lateral edges, just going straight through the middle there. Do not include the top and the bottom, the top triangle and the bottom triangle. Don't include those. The lateral area is just the faces through the middle. Alright, so let's do an example real quick. This one's pretty straightforward. We're going to find the lateral area, which we already saw was the perimeter of the base times the height. Lateral area equals perimeter of the base times the height. And to find the rest of that base, you use the Pythagorean theorem, which makes that hypotenuse the square root of 61. So we add 6 plus 5 plus the square root of 61, and we add that all together. That's the perimeter of the base, and then multiply that times the height of this thing, which is 7. We get 18.81 times 7, or 131.7 centimeters squared. Now, if we want to find the complete surface area, we just need to add the two triangles in. We've got a triangle at the bottom, and we have a triangle at the top. So we want to add those together, or we want to include those in the area. So if we want to find the entire surface area, we take the lateral area and add the two bases, which in this case are triangles. So the surface area is equal to 131.7, the lateral area, plus 2 triangles. Remember, triangle is 1/2 base times height, so we want 2 of those. So 2 1/2 times 6 times 5. 2 1/2 base times height, which gives you 161.7 centimeters squared. Alright, so what about surface area of a cylinder? Now notice when you have a cylinder, you've got the axis, which is the height, or we call it the altitude, either one, depends on what book you're looking at. Sometimes they call it altitude. You have the radius, and then if it's oblique, you still have an axis or a height, but the height is actually outside of the cylinder. The height has to be perpendicular to the floor, so that's why it's outside. So you have your cylinder and you have your oblique cylinder. Now, if we unfold this cylinder, this is what it looks like. It's basically a rectangle. If you've ever cut a toilet paper roll up the side, then you unroll it out, you can see that it's a rectangle. But the cylinder will include 2 circles as well. So if we want the total surface area of this thing, the surface area is going to be the rectangle plus the 2 circles. The area of both of those, all 3 of those things. Area of a rectangle is 2 pi RH. Why is it 2 pi RH? Because right here, let me change colors of my pen. Right here, this number represents the circumference of this circle from here to here. So the circumference is 2 pi r, and then we're taking that times the height. That finds the area of the rectangle. Then we need two circles. That represents this circle and this circle. So we add all of that together to find the surface area. So the lateral area alone is just the rectangle only. So we just need 2 pi r h. That's all we need. All right, so you've got lateral area and you have surface area. Let's do an example. All right, so you have a cylinder. The diameter of the cylinder is 15 millimeters and the height of this cylinder is 18 millimeters. Even though it's laying down, it's still the height. We're going to find the lateral area and the surface area of the cylinder. Remember, the lateral area is just the rectangle that you would get if you unfolded this thing. So 2 pi r h. The r is the radius and the 18 is the height, or the h is the height. So you get 847.8 millimeters squared. The surface area is going to be that lateral area plus two circles. You got to include the circle at the top and the circle at the bottom. So when you do the mathematicas, the math, you get 1,201 and 1/10 millimeters squared. The end. Thank you for watching. Thank you for playing. Bring your notes in to me tomorrow and I will give you some much deserved credit. Goodbye.